Hello. How do I see chat here? Hi, Lucas. Let me ping Emre. How does the sound? Is the sound okay? Or my voice? Nice. Wonderful. Okay. I have a few minutes till we can start. Nice. I did not think I was going to be nervous for this. Who knew? A bit too quiet. Maybe the mic volume is too low. Let me see if I can. I have it on maximum right now. Is it? Yes, the music is on purpose. Is the... Can you tell what I'm saying? Or is it too low? Better now. Okay. I can also just try to speak a little louder and hopefully that helps. Alright, awesome. I will try my best to keep talking as I'm solving. I think that's going to be the main challenge, is not to split my attention too much between focusing on solving the problems but also trying to explain my thoughts. This is definitely a new experience that I've not done before. I think we are... Oh, hi Shami. I think we are good to start soon. Unless there is anything else to check. When the music stops, the voice is fine. I can also just try to lower the music, see if that helps. In the testing round, Mehmet told me to have the music a little bit higher, and I thought that was a good idea. But if it's interfering, here maybe that helps. We can leave it at this state. Yay, math! Okay, do I have the timer here? Okay, the timer is ready, and I can start it. Can I get a final thumbs up if this is an okay state to get started? Yes, go. Okay. Awesome. Alright, let me start the timer and let's go. Okay. Try to scroll these here so they also become visible. Okay, problem 1. And in bed let's see, both live in Mathville. Andy leaves Mathville on his bicycle at 1:30, traveling north, steady 8 miles per hour. Betsy leaves on her bicycle from the same point at 2:30, traveling due east at steady 12 miles per hour. At what time will they be exactly the same distance from their common starting point? Okay, does the direction matter? No. Alright, well, if X here is the number of hours since Andy leaves, then Andy has traveled 8x, then Betsy has traveled 12 times x minus 1. We want these two to be equal. What does it give us? This gives us x equals 3. This gives us x equals 3. That means that at what time will it be exactly the same distance? 1:30 and 3? 4:30. That's an answer choice? Yes. Okay, moving on. A box contains... I am very slow in calculations. That is my biggest weakness. The problems I'm most worried about is these starting word problems. But so far so good. A box contains 10 pounds of a nut mix that is 50% peanuts, 20% cashews, and 30% almonds. Okay, a second nut mix contains 20% peanuts, 40% cashews, and 40% almonds. Is added to the box, resulting in a new nut mix that is 40% peanuts. How many pounds of cashews are now in the box? Okay, so our original box had 10 and it was split 5, 2, 3. So we had 5 peanuts, 2 pounds for cashews, and 3 pounds for almonds. And our second mix, we don't know, but it's x to x to x. And the new mix after everything is put together is 40% peanuts. So 5p plus x should be 40%, which is 2/5 of 10 plus 5x. Is that right? Yeah, there's no p here. I don't know why I wrote p here. So this corresponds to the peanuts, and then if we solve this, we have 5 plus x is equal to 4 plus 2x, giving us x equals 1. 6 out of 15. That is 40%. Okay, yep. All right. And then how many pounds of cashews are now in the box? So there was 2 and 2. That would be 4. So B. Okay, let's go to 3. A team of students is going to compete against a team of teachers in a trivia contest. The total number of students and teachers is 15. Ash, a cousin of one of the students, wants to join the contest. If Ash plays with the students, the average age... Oh, it's... Okay, one of these average... the average age on the team will increase from 12 to 14. If Ash plays with the teachers, the average age on that team will decrease from 55 to 52. Find the age of Ash. Okay, I don't see anything we can do immediately here, so let's just do this straightforward thing. Let's write out the equations. Let's say we have x students and 15 minus x teachers. Did you read this correctly, right? Okay, yeah, so those add up to 15. So x times the average, which would be the average student age plus Ash's is equal to 15 minus x times t. Right? Or what am I talking about? No, the total sum of the student ages is the student age times x. You add a, and then you divide by x plus 1. That's the new average. That should be from 12 to 14. So this would be the 14, and then, oh, okay, we have the s is 12. Okay. Don't need to. There. And then for the teachers, it was 55 to 52. So teachers are 15 minus x times 55 plus a over 16 minus x. This would be 52. Have I used everything? 2 equations, 2 variables. Okay. So we get here 2x plus 14 equals a. And then 52 times 16 minus x here is equal to a plus 15 minus x times 55. We want to find a, so we want to eliminate x here. Oh, do I have to do this multiplication? Oh no. Well, this would be a plus 15 times 52 plus 15 times 3 minus 55x, whereas the other side is 52 times 15 plus an extra 52, so 52 minus 52x is equal to this. Bring this to the other side, we have 52 plus 3x is equal to a plus 45. So a is equal to 3x plus 7. Okay, please be right. And then, okay, I mean, these are kind of nice numbers. X is 7 here, making a 28. Is that an answer choice? That is an answer choice. Okay. Might want to recheck the calculations on this one. Let's go next. Agnes writes the following 4 statements on a blank piece of paper. At least one of these statements is true. At least 2 of these statements are true. At least 2 of these statements are false. At least 1 of these statements is false. Each statement has a truth value. How many false statements did Agnes write on the paper? Okay. Let's see. We need to have at least 2 true or at least 2 false statements, which means out of 2 and 3, one of them has to be true for sure, which means the first one is true for sure, But then if the first one is true for sure, and then if one of the second and the third is also true, then we have at least two true, making the second one true as well. And then what? The second two cannot both be false because that would make the last one true. Oh, the last one has to be true. Can it be false? No, because then it would make itself.
On the news. Homes destroyed, loved ones lost. But an emergency.
Oops. Okay, so at least one of the is false has to be true, right? The last one cannot be false because then it makes itself true. But then the third one is false, and then that means that it is B. There's only one false statement. Right, the third one is. So that would be B. Okay, let's move on. In the figure below, the outside square contains infinitely many squares, each of them with the same center and sides parallel to the outside square. The ratio of the side lengths of the square to the inner square is k, between 0 and 1 strictly. The spaces between squares are alternately shaded as shown in the picture, not necessarily to scale. The area of the shaded portion is 64%. What is k? Okay, so these squares, I mean, this is a geometric progression. The squares have areas 1, the next one would have side length scaled by k, which means area scaled by k squared, and then k to the fourth, and so on. So the first shaded region would be 1 minus k squared. The second shaded region would be, it skips k squared minus k to the fourth, so directly to k to the fourth minus k to the sixth. And then so on. And this is 1 over 1 plus k squared. This is 64%, so that is 8/10 squared, 4/5 squared. Okay, 3, 4, 5 ratio here. That means k is 3/4. Is that an answer choice? Yes, that is D. Okay. 6 chairs are arranged around a round table. 2 students and 2 teachers randomly select 4 of the chairs to sit in. What is the probability that the 2 students will sit in 2 adjacent chairs and the 2 teachers will also sit in 2 adjacent chairs? Okay, round table. We have cyclic symmetry here. Let's say we have student 1, student 2, teacher 1, teacher 2. We can fix the location of student 1 with a loss of generality because they will have to sit somewhere. And then student 2 will have 2 options out of 5. So that would just be a probability of 2/5. But then what would happen to the teachers? After they seat, the teachers would be two times 4 is 2. So 12 locations. Out of those, 1, 2, 3 times 2, 6 of them work. So probability 1/2. That's 2/5 and then 1/2. That would be 1/5. Is that an answer choice? That is an answer choice. Yes, that is B. So yeah, here I'm conditioning on the fact that if I know that the 2 students are sitting together, then the probability of the teachers sitting together, it would have to be here, here, or here, and that covers 1/2 the remaining possibilities in that scenario. Question 7. In a certain alien world, the maximum running speed v of an organism is dependent on its number of toes n and number of eyes m. The relationship can be expressed as v equals n to the a, m to the b, centimeters per hour, where k, a, and b are integers. Okay, k and b are integers. In a population where all organisms have 5 toes, we have log v equals 4 plus 2 log m, and in a population where all organisms have 25 eyes, log v equals 4 plus 4 log n, where logs are base 10. What is k plus a plus b? Okay. What's going on here? We have log v is log k plus a log n plus b log m. And it says that in the situation when we have 5 toes, which one was toes, n or m? Toes was n. So if n is 5, then log k plus a log 5 plus b log m is equal to 4 plus 2 log m. And in a population where all organisms have 25 eyes, that would be log k plus a log n plus b or 2b log 5 is equal to 4 plus 4 log n. Okay, so the first equation is true for any m. Which means b is equal to 2. And then the second question is true for every n, which means a is equal to 4. But then we get log k plus 4 log 5 is equal to 4, and log k plus 4 log 5 here is also equal to 4. Okay, so yeah, that's, we don't need anything anymore. So, okay, what do we have here again? We have b is 2, a is 4, and then k is 10 to the 4th divided by 5 to the 4th, that is 2 to the 4th, so 16. 16 plus 2 plus 4, that would be 22. Is that an answer choice? It is an answer choice, okay, so we're doing C for this one. I also will probably want to check the calculation on this. Okay, the next one would be 8. Pentagon ABCDE is inscribed in a circle, and BC equals CD equals 30. Sort of draw a picture here. ABC, so E with BC, a 30-degree angle here and a 30-degree angle here. Something like this. AC and BD intersected point F. AC and BD intersected F here somewhere in the middle. Okay. And suppose that AB is 9. We have AB. AD is 24. 9 and 24. What is BF? Okay. The angles we have are this and this. is here. AC is here. Do I have the figure correct here? BEC. Oh, it's inscribed in a circle. Why did I skip that part? That is probably very, very important. Okay, cyclic here means that, okay, we have the arc BC and the arc CD. They are both subtending 30-degree angles. And we have a B and also a D. Is there anything clever we can do here? Okay, I mean, we could call this angle alpha here. That means, what do we have here? We have AD would be 2r sine of 60 plus alpha. They gave us this. And then AB would be 2r sine alpha. They gave us this as well. That is 2 equations and 2 unknowns. Presumably we can figure out r and alpha. Is there something better we can do here? BD would be 2r sine 60. And then BF. Am I I feel like I should be missing something here. Maybe because I drew a very terrible picture. We know this angle here is 30. We know this angle. No, we don't know that angle. Okay, let's skip this because I think this is either going to be an annoying calculation or I'm just missing something very, very obvious. Let's do some other easy questions first. Let W be a complex number 2 plus I. What real number R has the property that R, W, and W square are 3 collinear points in the plane? Okay, to be collinear here, we would want W squared minus W to be a real multiple of like something times W minus R. What is W squared minus W here? W times W minus 1. That would be 2 plus I times 1 plus I. That is 2 minus 1, 1 plus 3I. So we want 1 plus 3I to be a multiple of 2 plus I minus R. So 2 minus R would have to be 1/3. That makes R 5/3. Is 5/3 an answer here? That is E, yes. Okie doke. Question 10. In the figure shown below, major arc AD and minor arc BC have same center O. Okay. Also A lies between O and B. Okay. And D lies between O and C. Major arc AD, minor arc BC, and each of the following centers have length 2 pi. So AD has length 2 pi, minor arc BC, and each of the line segments AB and BC. What is the distance from O to A? Okay. What's going on here? If this angle was alpha, let's say, then let's say the inside radius of the small circle was x, then we have 2 pi minus alpha times x is equal to 2 pi. We also have, then the large circle would have radius x plus 2 pi, so x plus 2 pi times alpha would have to be equal to 2 pi. And now we have to solve for x. Okay, that means we have to eliminate alpha. Alpha here is equal to 2 pi over x plus 2 pi, so we get 2 pi minus that times x. 2 pi times 1 minus 1 over x plus 2 pi, so x plus 2 pi minus 1 over x plus 2 pi times x is equal to 2 pi. Cancel out the 2 pi's. X squared plus 2 pi minus 1 x is equal to x plus 2 pi. X squared plus 2 pi minus 2 x minus 2 pi equals 0. Please tell me I did this right. Okay, the angles here were, I shouldn't skip too many problems, so let's at least make sure we have this right. Angle is alpha, 2 pi minus alpha times the radius would be 2 pi. Okay, and then x plus 2 pi, the new radius times the angle alpha is also 2 pi. Looks okay. And then what are the answer choices looking like here? Okay, we have to solve a quadratic. So 1 minus pi plus minus 1/2 the square root of 4 pi minus 1 squared plus 8 pi. So okay, cancel out the 4 here, so it's the square root of pi minus 1 squared plus 2 pi, so pi squared plus 1. 1 minus pi plus square root, that is b. Okay. What's going on next? Question 11. The orthocenter of a triangle is the concurrent intersection of the 3 altitudes. What is the sum of the coordinates of the orthocenter in the triangle whose vertices are A, B, and C? Okay, is there anything special about these vertices? Where are they located? We have 2, 31, 8, 27, and 18, 27. I see. So one of the altitudes will just be this line. So we have to intersect the line x equals 2 with one of the other two altitudes. So let's say we can do this altitude from this vertex. What line is this? Well, this line is going to have, let's find the slope. So the slope from A to C is 16. So minus 16 over, no, it is plus, minus minus. So 16 over 4, that would be slope of 4. So this would be y equals 4x plus something. But it passes through 8, 28. So 4 times 8 here would be 32. And so it's 4x minus 5. And so we want to intersect this with x equals 2. That would give 8 minus 5, 3, y equals 3. 2, 3. 5 is an answer choice. So A, question mark. Yeah, maybe this figure was just not drawn to scale, but yeah, okay. I mean, yeah, it should be very easy to just do the equations of these lines, and if you are better at arithmetic than me, you will get the right answer there. Okay, let's do 12. 12 says, the harmonic mean of a collection of numbers is the reciprocal of the arithmetic mean of the reciprocals of the numbers in the collection. For example, blah, blah, blah. Yes, we know the harmonic mean. What is the harmonic mean of all the real roots of this polynomial? Okay, so we want to find 1 over R1 plus 1 over R2 plus 1 over R 4050. That is the same as looking at the last, doing Vieras, but on the reciprocal polynomial. So looking at the last two coefficients of this polynomial here. So for this polynomial, we have a final term of 3 to the 2020, negative 3 to the 2025 is the constant term, and then the one right before that would be 2025 times, or I mean negative 2025 times 4 times 3 to the 2024. So the sum of the reciprocals of the roots would be the ratio here, which is 2025 times 4 over 3, negative of this. And what do we want? We want the harmonic mean, so we want 4050 divided by this sum, giving us, so that cancels, you're left with negative 3 over 2. Negative 3 over 2 is B. Okay, 13. Let's see, is equal to 1, 2, 3, 13. Let n be the greatest integer such that there exists a subset of C with n elements that does not contain 5. There exists a subset that does not contain 5 consecutive integers. Suppose that integers are chosen at random. Okay. How many elements do we need to remove to make it so that there are no Obviously, n cannot be 13 because then you can't avoid having 5 consecutive integers. N cannot be 12 because you will either have 1 through 5 or what is it? 9, 10, 11, 12, 13. 9 to 13. But if you remove 5 and 10, then you can, yeah. So, okay. And here is equal to 11. The probability we want is, what is the numerator and denominator that we have here? 13 choose 2, same as 13 choose 11. And then the ones that work here are going to be the only probability that we are avoiding it or not avoiding. Do not include 5 consecutive integers. Yeah, there aren't many cases at all. You can either destroy 5 consecutive integers by removing, let's say, let's just list these. You can remove 5 and 10. That always works because things mod 5, you're not allowing something to be 0 mod 5, but you can also tweak this a little bit, so you can do 5 and 9. That also works. You can also do 4 and 9. Four and 10 is too big because 5 to 9 would be 5 consecutive integers. So 3. So this would be 13 times 6 in the bottom, leaving us with 1 over 26. Okay, that is an answer choice. I keep second doubting myself at every step here, but okay. We should also speed things up a little bit. Question 14. Here is going to be points of G and H are collinear with eccentricity E. The ratio of their areas is 2025, which we know is a square. 45 squared, right? So C over A is the distance from center to the focus. Let's just assume that the small ellipse has A equals or I guess we could do C equals 1. We could do C equals 1, and then that would be E minus 1. So we have a 1 and a 1 and an E minus 1. And then from the middle here to G, we have 45. And so the claim here is that 45 times E minus 1 is equal to actually E plus 1. Giving us 44E is equal to 46, 23 over 22. Is not an answer choice. Wait, what did I do here? So this is 1 and 1. E is the ratio C to A. Oh, E is the reciprocal here. So Yeah, okay, I did A over C. So if this was 23 over 22, then I guess I'm looking for 22 over 23, so D. Okay. Whoa, whoa, whoa. A set of numbers is called sum free. If x and y being elements means x, y is not in the element. What is the greatest possible number of elements in a sum free subset? Okay, this one is just straight up C. You can achieve this in multiple ways. I think the standard one is you just do 11 to 20 are all numbers that work. This question has a lot of history that I do not have the time to get to right now, but it's a very classic problem, and I'm very surprised that they would put it here. Okay, I'm running out of time here, so let's just speed through and just take the free point. Triangle ABC has side length AB equals 80, BC equals 45, and AC equals 75. The bisector of B and altitude AB intersect at point P. I need a picture for this. BC is small, AC is big here. B and altitude to side AB. Bisector of P. We want is BP. We have all the three side lines, so we have A, B, and C here. And okay, so we have A cosine B, and then we want to do A cosine B divided by cosine B over 2, because this is half the angle of B. Okay, and A here is 45. So we want to do 45 cosine B over 2. What are the cosines though? Okay, let's do some fun law of cosine calculation. We have c squared, or I guess I shouldn't even bother with this, it's just the numbers. 80 squared is equal to 45 squared plus 75 squared minus our cosine here, cosine B times 2 times 45 times 75. What does this give for cosine B? Oh no, calculations. We have 5 times 155 equals 45 squared minus cosine B times 2 times 45 times 75. There's at least a 5 squared everywhere, so we can divide by that, and then we get 31 is equal to 81 minus cosine B times 2 times 9 times 15. And so, okay, so then we get 50 divided by 2 times 9 times 15. So our cosine B is, will be a 5 on top, and then we get rid of a 5 and a 2 here, so 9 times 5 over 27. That makes cosine b over 2 be 32 over 27, 16 over 27, the square root of that. Wait, that doesn't give an integer. Hold on. Ta-ta-da. Okay, let's continue this in a bit. How am I doing with time here? Terrible. I told myself I wasn't gonna do this. I think I want to look a little bit further here into the other questions, and then just to gain some confidence a little bit. I think I can do this. Let's start with 20. The base of the pentahedron shown below is a 13 by 8 rectangle. We have the sides. Everything is isosceles, so we have a symmetry. What is the volume of the pentahedron? Okay, drawing some inspiration from the isosceles trapezoid here. I guess we can cut it into two pyramids. This is hard to draw. If we cut into two pyramids on the side, followed by a prism in the middle, those look like they are easy. We have 7, 3, 3. Do we know the altitude? These are 8. Okay, 13, 3 makes for square root of 160. Square root of 160, and then we need to subtract 16. We go down to 144, so 12. So we have an altitude of 12, so then we are doing 8 times 3 times 12 over 3, and then we are doing 8 times 12 over 2 multiplied by 7. Okay, so we have 8 times 12, that is 96, and then here we have a lot. 56 times 6, so that is 336, right? Putting everything together, this should be 432. That is not an answer choice. Hold on. 7 and 8. And 12. Okay. 8 times 3. Why is my arithmetic not working? Okay, next question. There is a unique order tripled AKM of non-negative integers such that 4 to the A... Okay, is this binary expansions? For sum of powers of 4, 964 times the sum of powers of 2. Can K be 0? if k was 0, we would have a power of 4 divided by a power of 2 equals 964, which is not a power of 2, so k is greater than 0. That means that if we multiply the denominator to the other side, and we look at the smallest power of 2, on the left we have 2 to the 2a, on the right we have 2 to the a plus whatever the valuation of 2 is of 964. 964 is 2 times 482, 4 times 241. That gives us a equals 2. Okay, if a equals 2, we can cancel that out. We're left with 1 plus 4 to the k plus 4 to the mk over 1 plus 2 to the k plus 2 to the mk is equal to 241. Let's multiply this to the other side. Can we do a similar trick? Subtract 1 to both sides, then we will have 2k is the smallest power of 2 dividing the left side, and then for the other side we will have 240 plus 241 times 2 to the k plus higher powers of 2. Can this tell us k here? Well, 240 here is 120 times 2, 60 times 4, 30 times 8, 15 times 16. So there's a 2 to the 4th here. So either k is 4, or k is 2. K cannot be 2. So k is 4. Then what is m? This would be 4 to the k to the m plus 1 minus 1 over 4 to the k minus 1, and then 2 to the k to the m plus 1 minus 1, or I mean divided by, over 2 to the k minus 1. Right? So we get 2 to the k m plus 1 divided by 2 to the k plus 1. And if k here is 4, that makes 241 times 17 minus 1 equals 16 to the m plus 1. Okay. Something's wrong here. This 241 is 256 minus 15. Okay, so m is 2. K4, M2, 4 and 2, 6, and then A we said is also 2. That's 4 and 2 and 2, this is 8. So A, we're saying A for 21. Okay, 22. 3 real numbers are chosen independently and uniformly at random between 0 and 1. What is the probability that the greatest of these 3 numbers is greater than 2 times each of the other 2 numbers? Okay, there's a classical problem like this that asks for triangle inequality. We are doing just maximum is greater than or equal to the other 2. That means if the maximum is located somewhere here, the other 2 are located in this region, that happens with probability 1/4. That doesn't care where x is. Okay, let's move on. 23. Call a positive integer fair if no digit is used more than once. It has no zeros and no digit is adjacent to 2 greater digits. For example, 196, 23. Also no zeros. Okay. How many fair positive integers are there? Okay, so there cannot be a minimum inside the number. The smallest digit cannot appear. So then the small digit must be on the side. That means what is happening? We can start building from the minimum digit, let's say on the left or on the right. The next one, the next smallest would also have to be extremal on the left or on the right until we get to a peak. And then, okay, so it's a single peak. So we are increasing and then we are decreasing. If we have selected the integers as a subset here, then there is, you're just choosing which subset to put to the left of the maximum. That is, okay, if we picked k digits, then it's 2 to the k minus 1. 9 choose k. We want to sum this all over k. That is not even. It's not including 0, so it's okay, so it's the sum of like 9 choose k times 2 to the k, giving us 3 to the k. We want to subtract 1, we want to divide by 2. Not 2 to the k, 2 to the 9. What is 3 to the 9th minus 1 divided by 2? That's a very big number. Okay, this is going to be 81 times 81 times 3 minus 1 over 2. 6,400 and something times 3, that is 19,000 or so divided by 2. It seems like C is the only answer here that is close to that, if I did my arithmetic right. Okay, and then let's move on to the next question here. 24. 24 here says circle of radius r is surrounded by 12 circles of radius 1, externally tangent to, okay. We just want to, whenever you see circles that are tangent, you just want to join the centers of the circles. We have r plus 1, 2. We have an angle of 2 pi over 12, pi over 6 here. And we need to just find r. Law of cosines, r plus 1 squared times 2 minus 2 root 3 over 2 r plus 1 squared is equal to 4. So r plus 1 squared here times 2 minus root 3 is equal to 4. That is the same as 4 times 2 plus root 3. We want to r plus 1 squared equals that, and then we want to take the square root of this. What's something nice here that has a square? I'm going to borrow this as 2 times 1 plus root 3 squared. So r plus 1 here ends up being root 2 times 1 plus root 3. So we have root 2, root 3 minus 1. Root 2, root 6. 2 and 6, 8, minus 1, 7, that is a C. 25 polynomials, P, X, and QX each have degree 3 and leading coefficient 1. Their roots are elements of 1, 2, 3, 4, 5. The function has the property that there exist real numbers a, b, c, d, such as a set of all real numbers less than or equal to 0 consists of the closed interval ab together with cd. So you want the closed interval first and the open interval second. That means you want the graph to look like something like this, where you have a and b, but then you want asymptotes, and then you want a negative over here. So in total, we want, okay, this is going to be casework. It's something like you either want 1, 2, and then 3, 5. I mean 1, 2, and then 3, 5, and then you want 1, 3, and then 4, 5, or 2, 3, and then 4, 5. How many ways can you achieve each of these? This specifies the zeros, this specifies the poles, and then you can throw something. You cannot mess with the zeros. You cannot add multiplicity there, nor can you add them as poles, unless you add them as poles with multiplicity 2. No, you can't do that. So you just have to throw away. Okay, this seems easy, but it's casework, so I'll use my time to go back a little bit now and do some more problems. Okay, 19 seems doable. 19 here says a, b, and c are the roots of the polynomial x cubed plus kx square plus 1, kx plus 1, no x squared. What is the sum? That. Okay, that's a symmetric expression. We can make it out of the symmetric a squared b squared times a plus b plus c, but then we would have to subtract anything that is the symmetric a squared b squared c. Okay. We have a plus b plus c is 0. We have ab plus bc plus ca is equal to k, and we have abc is equal to negative 1. Wait, did I do this right? A squared plus b squared plus c squared. So 3 times 3, this is 9. Yes, you should get all 3 of those here. But that means this is 0, and that means this is ABC. Oh, okay, I see. So the other one is minus k. So k. So E. Okay. 18. How many order triples XYZ of... Oh, time is running out. How many order triples XYZ of distinct non-negative integers less than or equal to 8 satisfy these inequalities? Okay, casework. Casework by what? The smallest one cannot be 1. If it's 2, you want to avoid things like 2, 3, and something high, 2, 4, and something high. Okay, it seems like it's easier to just see what needs to be avoided. since they are distinct, they can come out of choosing 3 numbers out of 2 to 8, which is 7, so 7 choose 3. We want to subtract exactly 2, 3, and then either 6, 7, or 8, and 2, 4, and 8, and 3. No, 3 is too big. That is 4 things that are being subtracted. This is 7, 6, 5 divided by 6, 35 minus 4, 31. That's not an answer choice because we need to multiply by 6. 31 times 6 is 186. That is C. Okay. Let's keep going. Oh, we almost went back to where we were before. 17. The polynomial z plus I, z plus 2i, z plus 3i plus 10 has 3 roots in the complex plane. What is the area of the triangle formed by these 3 roots? Okay, we just did polynomials in a recent chapter today. We were saying that if you have to find the roots of a cubic, you have to guess a root. So let's try to do that. Obviously it's not 0. -1 plus 1. Okay, we're working with complex here, so the simple numbers are a little bit different. 10 in Gaussian integers factors, so it factors as 2 times 5 is 4 plus 1, so 2 plus I times 2 minus I, and we want this to somehow match the other side. Oh, okay, so there you go. One root is if z plus 2i is your 2. So z equals 2 minus 2i. Because that's the central thing in the arithmetic progression of difference I here. And now what? We have to factor the rest and solve the quadratic. Let's square this so we have one root. Let's see, so we start with z cubed plus 6i z squared. So when we take out a z minus 2 plus 2i here, we will be left with a z squared, and the sum of the roots now, instead of 6i, will be, or instead of negative 6i, it will be negative 4i minus 2. So plus 4i plus 2z. And then the product of the roots here was negative 6i plus 10. And then we are dividing by 2 minus 2i, or minus 2 plus 2i, so we want 5 minus 3i divided by no, let's just divide by 1 minus I here. That's the same as multiplying by 2 and multiplying by 1 plus I and dividing by 2. That would be 5 plus 3. So we would have 8, and then so plus 4 minus I minus 3i, no, plus I, plus 4 plus I equals 0 here. We would want these roots, and these would be if I did my calculation right here, hold on. It was minus 6i plus 10 was the constant term, and if we remove one root from that, oh, it would have to be negative as well. Five minus 3i times 1 plus I here would be 5 and 3, 8 for sure, so you get the 4. And then 5i minus 3i, 2i, and the I. So 4 plus I, but it would be negative 4 plus I here. Because the original product was 10 minus 6i. The original product of the roots was negative that. Yeah. Is there any nice roots here? I guess we can always check by seeing if the discriminant has a perfect square here. Why is arithmetic so hard? 4i plus 2 squared here would be 4 minus 16, so negative 8. Plus 16. So we will go back to the 4. Something doesn't seem right here. Oh no, I can't solve quadratic equations. How's the time? Oh, we did really poorly this exam. Maybe instead of the quadratic equation, I can go back and find an answer for... which one did I skip? 20. This... Why couldn't I get an answer for the volume here? Oh, because I added only one 96 instead of two 96s. Okay, so that is 100 and 100 and 300. That's 500 something. So we have 500, but then we borrowed 8. So 828. Sorry, 528. So C. Okay, C for that. Okay, that's fixed. What else did we have? I feel like I skipped something here that I thought I was going to look back. Yes, number 16. I had the cosine here, but I wasn't getting the number right. Why did we not get an integer? We didn't calculate the cosine right. So here, yeah, so it was this, and then 1 plus cosine b over 2 would, the square root of that would give us the cosine b over 2, and then we would plug it into this to find the value. But for some reason, I must have made a mistake here somewhere. I think I can call it here, because, yeah, the timer is out. Wow, very, very disappointing. I guess I'm too slow for this. Teacher is too slow. Let's look at the chat.
Why spend hours on complex video platforms?
Not another ad here accidentally. We can just close this. Okay, so how do I grade this? I would have the answers. I think Emre has the answer key. that I could compare it with. Yeah, the problems seemed very standard. My slow calculations aside, I didn't see anything. I was disappointed that some of the questions were actually very, um, what was it? The one with, yeah, the sum free. Question 15 is, I think, a little bit. They could have at least disguised it by changing the wording. Um, it felt like there was more counting. The geometry was relatively straightforward. Not much number theory either. I did like seeing the ellipsis question. I do like that the AMC is involving a lot of a lot more questions now from the sort of 12th grade topics. Thank you. Let's see. I also wanted to spend. I wish I had more time with 25 here, but I had to sacrifice it because you can just tell from the type of question that it's going to. We just need to check the cases for the poles and the zeros. Hmm. You can have things like x minus 2, x minus 3, then you can't touch it anymore once it's in the top. You would have x minus 4, x minus 5. Um, we cannot mess with the roots, so we would have to only use the poles here, so you could add an extra x minus 4 on both sides. This doesn't affect the function. You could add x minus 5. That similarly doesn't affect the function. So that is just one way to do that. There's one way. The case for 1, 2, 4, 5, that can have an x minus 1, x minus 2, and you will have an x minus 4, x minus 5. You can do something similar to the previous case, but you can also do an x minus 3, x minus 3 on both sides. This doesn't affect the signs, but it changes the function because it introduces an extra point of where it's not defined. So 1, 2, 1, 3, 2, 3 with 4, 5. But you can also do 1, 2, 4, 5. Wait, I guess that was missing here. There was also 1, 2, and 4, 5. I mean, also with the poles, you don't want to change the multiplicity to even either. So the answer is not just 4, right? What are the answer choices here? No, they have to be at least 7. So what are we missing here? Let's see. We could have 2, 3. Let's just do a new page. So our casework is saying that either the non-negativity will happen in such a situation, or these ones will be 4 or 5. There's 5 of these, and they can all be lifted to solutions. We said 1, 2, 4, 5 can be lifted into 2 solutions, depending on whether we introduce x minus 3 over x minus 3 or not. So far we have 6 things. There have to be more. A lot of these, I think, like 2, 3, 2, 3, this will be x minus 2, x minus 3, with an x minus 4, x minus 5 in the bottom. This you'd have to abrade it by doing an x minus 4 and an x minus 4, right? You cannot touch 1, 2, or 3. Oh, you could touch 1. You could do this. I see. Okay, so this has 2 solutions. 1, 3, 4, 5 is just 1. 1, 2, 3, 5 is just 1. And 1, 2, 3, 4 you also has 2, because you can do x minus 5, x minus 5, or you can just abrade that. And so then it is 5 plus 3, 8. Also not an answer choice. Okay, but at least now we know that it's not A. Okay, we have 8 things. Yeah, this one would be about being careful not to miss any. I'm reading the AOPS thread for number 25, and it seems like there might be an error. Oh. That would be very unfortunate for the exam if the question had an error. Yeah, listing the 8 functions is pretty straightforward. Okay, so you're saying it is 8 and there's just nothing we can do. Okay. Okay. Oh, I believe I got the answer key here. Let's see how terribly we did. Okay, so far it is 3 correct. That's 6 correct, and then 7. Oops, I never answered 8. We left it on, and then we have 8, 9, 10. Plus 2 would be 12. Plus 2 would be 14. And then 15, 16, 17, 18. and 19. We only got 19 questions right. And left the other ones blank. That is, yeah, what happens when you're very, very slow, which is why it is important for students to be a lot faster with the. What is 16 answer? 16 was the question. Um, oh, 16 was the one with the triangle that I skipped, and it is a D. It's supposed to be D. Let's go back to the 16. I think that was an interesting one. Oh, that was the one with the cosine, right? With the cosine of B. Yeah, okay, that one is just you just need to do law of cosines carefully. So yeah, I don't know if this was helpful in any shape or form. I think as far as what helped me get a lot of questions right, given my weakness of did you answer 17? So given my weakness being arithmetic, at least hopefully I showed that if you have some advanced knowledge, especially in the counting and algebraic side, that can pay off as well by solving some other type of question. Number 17 was yeah, that was the one with the quadratic that I also left blank because I didn't. It was a nice transformation that solves it really quick. Okay, I see your previous comment. Yeah, yeah, yeah. I was also thinking something similar. That's that's how we found the z equals 2 root there. Yeah, we could have just done the transformation right away and then just not bothered with the. Yes, that is very good. Z cubed there plus z plus 10 equals 0. It's much nicer. And then yeah. Oh yeah, that is perfect. That helps with the calculation as well. Very nice. Yeah, I actually liked 17. That's as far as making questions with complex numbers, it was a very creative way of phrasing it. Okay, I don't know if there's anything else left to touch on this. Hopefully the next life solve will go much better. I do feel really bad about the 25th problem being, if you guys are correct about the question being phrased without a correct answer. That seems very. I don't know what the policy is for how they deal with that. I believe they would have to void the question entirely. Okay, I'm sure we'll hear an update soon. Okay, everyone. Thank you to everyone that showed up. Thank you for all the encouragement. I will see you next time. The next live solve would be for AMC 12B, I believe on Friday, November the 14th, same time at 7 p.m. Thank you, everyone. And